What if one technology could turn lines of code into unbreakable financial agreements that run automatically, without banks, lawyers, or middlemen? And it's already powering trillions in value. The global financial system currently operates on a web of fragmented, siloed databases that require manual reconciliation, human oversight, and days of settlement time. This friction is a multi-billion-dollar tax on every transaction made today. That's the problem Ethereum was built to solve. Today we explore why this network is considered the backbone of programmable finance, what it actually provides for the institutional world, and the key questions defining its future. What real-world friction does it remove? Is the core infrastructure credible? How do its mechanics drive value? And what are the systemic hurdles it faces on the path to becoming the global settlement layer? This is for education, not financial advice. Crypto is high risk. Also, some links in the description are affiliates that help support the channel at no extra cost to you. Always do your own research. Section 1. The Architecture of Sovereign Computation. As we covered in our DLT Foundations episode, distributed ledger technology opened the door to programmable, trustless systems. While Bitcoin proved we could have a triple-entry ledger for money, Ethereum took that idea further and built a world computer. Proposed in late 2013 by Vitalik Buterin, Ethereum moved the industry from sovereign money to sovereign computation. The Ethereum core team was public and technically vetted from the start. This early transparency was critical for the institutional trust it enjoys today. The original white paper outlined a platform that could run general-purpose code, meaning any contract, agreement, or financial instrument could be digitized, automated, and enforced by the network itself. Credibility comes from results. The network has run continuously for over a decade, survived multiple protocol-wide upgrades, and successfully transitioned its entire consensus mechanism from energy-intensive hardware to a capital-secured proof-of-stake model. Today, development is led by the Ethereum Foundation and a global, decentralized network of contributors, ensuring that no single entity, not even the founders, can unilaterally stop the machine. For institutional allocators, this unstoppability is a primary feature, not a bug. Section 2. Protocol Mechanics and Economic Design. To understand why institutions are building on this network, we must look at the Ethereum Virtual Machine, or EVM. This is the global environment where all smart contracts live. Every node in the network runs the EVM, ensuring that if a contract says, "release funds if X occurs," the network will execute that command perfectly across thousands of servers simultaneously. The native asset, ETH, is the fuel for this machine. Every transaction requires a small amount of ETH, referred to as gas, to pay for the computational work. However, the economic design has evolved significantly. Under the current burn mechanism, a portion of every transaction fee is permanently removed from the supply. This means when network activity is high, the total supply of ETH actually decreases, creating a scarcity model that is tied directly to the utility of the network. Recent upgrades have introduced account abstraction, allowing users to sign transactions with standard biometrics or recover accounts without complex seed phrases, a massive leap for consumer adoption. On the validator side, stakers now secure the network with tens of billions of dollars in capital. A single validator can stake significant amounts of ETH to earn a yield, turning ETH into what many analysts call a digital bond. It provides a native rate of return for those who provide the capital to secure the infrastructure. Section 3. The Institutional Settlement Layer. Is there a working product with real traction? The data suggests we have moved well beyond the experimental phase. Ethereum is now the primary settlement layer for the world's most significant stablecoin supply and real-world asset tokenization projects. Billions of dollars in US treasuries, corporate bonds, and institutional funds have already been moved onto the ledger. major asset managers have launched tokenized funds directly on the mainnet, citing the ability to settle trades in seconds rather than days. This is where utility meets adoption. It's not about the price of a token, it's about the fact that a $100 million trade can be settled with the same efficiency as a $10 transaction. The ecosystem currently commands the largest share of locked value in decentralized finance. While other networks focus on high-speed retail trading, Ethereum has positioned itself as the high-value settlement layer. Much of the high-frequency retail activity has migrated to Layer 2 solutions, separate networks that process transactions quickly and then settle the final data back to the Ethereum mainnet for security. This modular approach allows the network to scale without compromising the decentralization that makes it valuable to institutions. Section 4. Privacy, speed, and technical evolution. The next phase of evolution focuses on two critical needs: privacy and throughput. For a corporation to use a public ledger, they need to ensure their proprietary trade data isn't visible to competitors. This is driving the adoption of zero-knowledge, or ZK, privacy technology. These upgrades allow the network to verify that a transaction is valid without revealing the sensitive details of the transaction itself. On the performance front, the protocol is moving toward parallel transaction processing. Historically, the network processed one transaction at a time. Newer upgrades are designed to let the network handle multiple tasks simultaneously, vastly increasing the transactions per second and reducing congestion. Furthermore, account abstraction and smart accounts are turning the user experience into something that looks and feels like a standard banking app, but with the underlying security of a decentralized network. This removes the technical barrier that has historically kept mainstream users away. We are seeing the infrastructure transition from a playground for developers into a professional-grade financial stack capable of supporting global commerce. Section 5. The path to global integration. Systematic hurdles. Despite its lead, the path to global integration is not without systemic hurdles. The primary challenge is the blockchain trilemma, the struggle to maximize security, decentralization, and scalability simultaneously. While Layer 2 solutions have helped, they introduce liquidity fragmentation, where capital is split across different subnetworks. Regulatory clarity remains the largest looming factor. The global landscape is currently harmonizing rules around which assets are considered commodities versus securities. While significant progress has been made, the programmable nature of smart contracts means they often fall into gray areas of the law. Ecosystem competition is also intensifying. Other high-performance platforms are optimizing for speed and low cost, challenging the settlement layer moat. Furthermore, as more value moves onto the chain, the honeypot effect increases. Security milestones must be met with every upgrade to ensure that trillions in value remain safe. In conclusion, Ethereum is no longer just a crypto project. It is a foundational piece of digital infrastructure that solves the problem of trustless, programmable agreements at a global scale. Its tokenomics have shifted toward a utility-driven scarcity model, and its adoption by the world's largest asset managers proves that the transition is underway. The path forward involves navigating the trade-offs between speed and security, but the network's established liquidity and developer moat make it the benchmark for the entire industry. What surprised you most about the shift from world computer to global settlement layer? Drop your thoughts in the comments below. If you're ready to take the next step in navigating this landscape, check the links in the description for the vetted tools and resources we use. Thanks for watching Crypto Pulse 360. Stay pulsed.